Hey everyone, and welcome to This Explainer. I am absolutely thrilled to be here with you today because we're tackling one of the most foundational and honestly, sometimes deeply misunderstood concepts in all of software engineering. Today, our goal is to completely demystify how Java objects work. We're going to break down how object-oriented programming, or OOP, takes physical reality, the actual things you see and interact with every single day, and seamlessly translates them into logical code syntax. It's this fascinating journey from a real-world concept straight into a digital reality. By the end of this, I promise you're going to see Java in a whole new light.
Okay, let's dive into this agenda so you know exactly what we're unpacking today. First, the real-world connection. Second, classes as blueprints. Third, attributes and methods. Fourth, interacting with objects. And finally, core OOP principles. Let's get right to it. Section 1. The real-world connection, from reality to code. Now, before we even look at a single line of Java syntax, we really need to establish a core philosophy. You see, object-oriented programming wasn't just invented arbitrarily out of thin air. It was intentionally designed to mirror how we as human beings naturally perceive real-world entities. So what exactly is an object? Well, I want you to step away from your keyboard for just a second and think about your immediate physical surroundings. How do you categorize the things around you? Seriously, look around you right now. You might see a phone sitting on your desk. Maybe you're clinging to a coffee mug like most developers do. Perhaps you're speaking into a microphone. In the real world, these are all objects. And in programming, an object represents these exact real-world entities. Every physical object has three dimensions: a unique identity, a current state, and a specific behavior. I mean, it's totally possible to have two coffee mugs that look completely identical, right? But they occupy different physical spaces, so they have unique identities. And this is exactly how Java models data. Section 2. Classes as blueprints, the idea versus the creation. And this brilliantly illustrates the next big concept. Before we can create a digital coffee mug or a digital car in Java, we need a template. We can't just manifest objects out of thin air in our code, we absolutely need a master plan to define their characteristics. On the left here, we have the class. The class is the blueprint. It's a user-defined data type that describes what the object will be, but it's entirely separate from the object itself. On the right, we have the object, which is the actual instance. This is the tangible creation that gets stored in a physical location in Java's memory, which is known as the heap. Think of the class as the architectural drawing of a house, and the object as the actual physical house you can walk into. You can use one single blueprint to build thousands of unique houses.
Section 3. Attributes and methods, anatomy of an object.
To really break down this internal anatomy, let's build a digital car. Every object is made up of two primary components, and the first is its attributes. Attributes are simply the data or characteristics that an object has, representing its current state. The crucial point here is that attributes are the specific, granular details an object possesses. They effectively make up its distinct identity. Just like if you think about a person, their attributes would be things like their name, their age, their height, and their weight. So what does a car have? If we build our car class, we need to declare variables to hold all this data. We might have a make, which we'd store as a string of text, like Ford. We'd have a model, another string, let's say Mustang. We'd need a year, which is a whole number, so we use an integer data type, like 2025. The price requires decimals, so we'd use a double data type to store $58,099. Hopefully you've been saving up. And finally, we need to know the state of the engine. Is it on or off? We use a Boolean data type for is running, and we can initially set that to false. These are the things our digital Mustang inherently has. But an object isn't just static data sitting there. It actually does things. This is where we transition to methods. Methods define the actions or behaviors that an object can perform. They are essentially collections of code statements grouped together to execute a specific task. And when we define a method, we also give it a return type. Now, if a method just performs an action but doesn't actually need to hand any data back to us, we just use the keyword void. So what can our Mustang do? Well, we could write a start method, we could write a stop method, a drive method, and a break method. Now, here is where it gets really cool. Calling these methods can actually update the car's attributes internally. If I call the start method, the code inside that block will reach into the car's attributes and actually change that isRunning Boolean from false to true. So the behavior directly modifies the state. Section 4. Interacting with objects, the mechanics. Let's move on and see how this builds in practice. Now that we understand the theory of blueprints, attributes, and methods,
How do we actually pull this off in Java? Let's walk through the exact 3 steps required. Step 1, we have to create the object. We do this using the new keyword. We type car, give it a variable name like my car, and set it equal to new car. That tells Java to allocate memory right there in the heap for our object. Step 2 is the magic key, the dot operator. If you try to print your car object directly, Java just spits out a random memory address. To get inside the object, you type your variable name followed by a period, the dot operator. Finally, step 3, we access the attribute or call the method. So typing mycar.start tells our specific Mustang to run its start sequence.
Section 5, Core OOP Principles, Beyond the Basics.
Up to this point, we've really just looked at a single isolated object, our Mustang. But to truly master how Java objects work, we need to zoom out and understand the broader paradigm that makes object-oriented programming the absolute industry standard for massive software systems. I mean, why go through all this trouble? Well, setting up classes and objects massively improves code reusability, maintainability, and scalability. It fully supports the DRY principle, don't repeat yourself. If you need 100 cars in a video game, you definitely don't write the code 100 times. You write one class and you instantiate 100 objects. This is what allows teams of developers to build massive, scalable applications where code is organized into logical, manageable units. And creating classes and objects is really just the foundation. From here, OOP opens up 4 powerful pillars that will be your next steps in mastering Java. There's encapsulation, which acts as a protective shield to hide your data. There's abstraction, which hides complex implementation details behind simple interfaces. It's just like how you press a button on an ATM without needing to know how the bank's server routing works. There's inheritance, which allows new classes to adopt the traits of existing ones, kind of like a dog class inheriting from a broader animal class. And finally, polymorphism, which lets single methods take on many forms depending entirely on the context. But before we wrap up this explainer, I want to leave you with a critical question to ponder. We built a beautiful car blueprint today, right? But we hard-coded the attributes. Every single time we type new car, we are going to get a Ford Mustang year 2025 worth $58,000. But what if we don't want every single car to be exactly the same? What if we want to create a customized Toyota or a Honda right at the exact moment of creation? Well, our current hard-coded blueprint actually has a pretty critical flaw. To solve it, we're going to need a special tool called a constructor, which will allow us to pass unique arguments the exact second our object comes to life. But that is a puzzle we will solve in our next explainer. Thanks so much for joining me today, and keep exploring.